Okay, my dears, we're going to do dilations day 2 now. So if you take that part of the packet out, otherwise it's in OneNote. And please do the do now. You can pause here and do the do now. That's on you guys. It's good practice, so please try doing it. Okay, so the scale factor is 5. Where is point A located? So here's A right now, or rather, where's point A prime located? So A right now is at 0.25. I'm going to write this a lot neater. Give me 1 second. Okay, so right now, A is at 2, 5. Where is A prime? Well, the scale factor of 5, which means I'm going to have to multiply each of these by 5. So if we think back, we could just do multiply by 5, multiply this by 5. A prime is equal to, or rather will be at, 2 times 5 is 10. 5 times 5 is 10, is 25 rather, 10. So A prime should be at 1025. Number 2, the scale factor is 3. Where is point B prime located? This is a different problem. Well, B is at 6, 2 currently, right there, right? 6, 2. B prime, well, the scale factor is 3, so I'm going to multiply the x by 3 and the y by 3. 6 times 3 is 18. 2 times 3 is 6. 18, 6. Number 3, the scale factor is 10. Where is point C prime located? So C right now is at 9, 9. If the scale factor is 10, I'm multiplying it by 10. 9 times 10 is 90. 9 times 10 is 90. D. C prime is going to be at 90, 90. And lastly, the scale factor is a half. Where is point B prime located? So B is at 6, 2. Now my scale factor is at a half, so I'm going to multiply that by a half. Multiply by a half. Put that in the calculator, or remember that multiplying by 1/2 is the same as dividing by 2. So 6 divided by 2, or 6 times a half, is 3. 2 times a half, or 2 divided by 2, is 1. So B prime should be at 3, 1. Okay, so let's move on. Remember, a key idea to remember about similar figures is the shape and angle measures of the figures remain the same. So, shape and angle measure of the figure remain the same. The size of the figure changes. Okay? In triangle ABC, triangle A and angle A and angle C are both 45 degrees. So this angle is 45 degrees. And this angle is also 45 degrees. In triangle DEF, angle F and angle D are also 45 degrees. Are these two triangles congruent or similar? Well, congruent means same shape and the same size. Are they the same size? No. So they are not congruent because they are different sizes. Are they similar? Well, they are the same shape, and because two of the angles are congruent, then that means that they are similar. Remember that similarity has same angle measures. If we go back to when we said determining shapes are congruent, one of the ways described was that they have the same angles right up here, right? They have the same angles. So they are congruent, they are rather similar because they have two congruent angles. And if you remember what we learned last year about triangles, a whole triangle has an angle measure of 180 degrees. So if this is 45 degrees and this is 45 degrees, 45 plus 45 is 90. 180 minus 90 equals 90. This angle must be 90 degrees. And so this angle must also be 90 degrees. So since you have two congruent angles, you will automatically have all angles congruent as well, because the third one has to add up to 180. Okay, let's move on. L prime, M prime, N prime is a dilation of LMN. Are the two triangles congruent or similar? Well, let's see. They don't really tell us any angle measures, so we'll have to see if we have a scale factor. So they're definitely not congruent, right? They are not congruent because they're not the same size. Let's see if they are similar. Well, if they are similar, then their lengths are going to be in proportion. So let's take the length of MN, and it should match up to M prime, N prime. So MN should match up to M prime, N prime. Okay? Well, do we know how long that is? We don't really, because it is so diagonal. We haven't learned how to do any diagonals yet, so that's not a good one to pick. We want one where we can see and count the units. So if we look at ML and M prime, L prime, those are nice and straight. So I would say, assuming yes, they are similar, because it looks like they're the same shape, but let's prove it. Same shape. So how long is line segment ML? Let's count. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 6, that is 15 units long. So ML is 15 units long. M prime, L prime, let's see, is 1, 2, 3, 4, 5 units long. So what's the scale factor? Well, let's see. M prime, L prime over ML will have 5 over 15. We have 1. Oops, not 1/5. I lied. 1/3. Okay, so K is 1/3. What that means is that M and L went through a scale factor of 1/3, dilated for 1/3 to get to M prime, N prime, L prime. And I know that here we called it LMN. It's the same thing because orientation is preserved. Okay? Now, given rectangle ABCD, dilate the rectangle by a scale factor of a fourth. So I like to write them out vertically. So let's see. My A is -8, 4. My B is -8, -8. I'm just going to move this over a little. My C is, oh, I'm sorry, I messed up. This should be +8. +8, I'm in the positive direction. My C is -8, -8. And my D is -8, +4. Now I am going to multiply by a scale factor of a fourth. So this is going to be multiplied by a 4, multiplied by a fourth, multiplied by a fourth. And if we remember what it means to multiply by a fourth, so remember that multiplying it's like serial killer handwriting here. Multiplying by a fourth is the same as dividing by 4. Okay, so at the end, what we're going to get, our A prime becomes 8 times a fourth is the same as saying A divided by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Our B prime, well, multiplying by a fourth is the same as dividing by 4. So 8 times a fourth is the same as saying 8 divided by 4 is 2. And -8 times a fourth is the same as -8 divided by 4, which is -2. And as we continue, we'll have -8 times a fourth, which is -8 divided by 4, which is -2. And for D prime, 4 divided by a fourth is the same as 4 divided by 4, which is 1. So now we're going to graph these. We have A prime is 2, 1.